Most of the existing drainage systems in Samshuipo, Cheungshawan, and Laichi-Kok were built more than 40 years ago. Owing to rapid developments and changes in land use over the years, the capacities of the existing drainage systems can no longer achieve the required flood control standard. In this regard, the Drainage Services Department revised the scope of the Laichi-Kok Transfer Scheme in 2005, which comprises the construction of the Laichi-Kok Drainage Tunnel and the Inter-reservoirs Transfer Scheme, IRTS, for improving the capacity of the drainage system at the aforesaid districts. The Laichi-Kok Drainage Tunnel was completed in 2012 to intercept the surface runoff from the uphill catchment areas for direct discharge into the Victoria Harbour, whilst the construction of IRTS commenced in February 2019. Kowloon Group of Reservoirs comprises Kowloon Reservoir, Kowloon Bywash Reservoir, Kowloon Reception Reservoir, and Shekley Reservoir. Before implementation of the IRTS, a large amount of surface runoff is collected in the reservoir through its catchment area, causing a rise in reservoir water level during heavy rain. The overflow enters the urban area of West Kowloon, and as a result, Laichi-Kok, Cheungshawan, and Samshuipo are prone to flooding threats. The IRTS includes the construction of a 2.8-kilometre-long water tunnel connecting Kowloon Bywash Reservoir and Lower Shingmun Reservoir. Prior to heavy rainstorms, the water stored in Kowloon Bywash Reservoir will be conveyed to Lower Shingmun Reservoir in advance to provide an approximately 350,000 cubic metres flood storage space in Kowloon Bywash Reservoir, which is equivalent to the capacity of 150 standard swimming pools. This storage capacity allows for collection of the surface runoff in Kowloon Bywash Reservoir during heavy rainstorms and reduces the chance of overflow entering the urban areas. As a result, flood prevention of Samshuipo, Cheungshawan, and Laichi-Kok will be enhanced. As the works area are located within the water gathering ground and the Kamshan Country Park, the contractor adopted the construction method using tunnel boring machine, which induces less vibration to minimize the disturbance to the surrounding environment. During excavation, the tunnel boring machine is able to simultaneously install the precast segmental linings to shorten the construction duration. Due to the geological constraints at Kowloon Bywash Reservoir, the project team assembled the launch and tunnel boring machine at Lower Shingmun Reservoir. The upwards movement of the tunnel boring machine can also minimize the risk of water ingress from Kowloon Bywash Reservoir during the tunnelling works. Prior to the commencement of boring, the project team constructed a temporary cofferdam at the Lower Shingmun Reservoir to isolate the construction site from the reservoir. Excavation and lateral support works followed to form a flat working platform for subsequent assembly of the tunnel boring machine. Upon completion of the tunnelling works, the tunnel boring machine will be disassembled and retracted to Lower Shingmun Reservoir, and then the construction of the outfall structure will commence. A smart penstock will be installed at the intake structure of Kowloon Bywash Reservoir. The flow through the tunnel can be closely controlled by the real-time monitoring of the water level at Lower Shingmun Reservoir. During heavy rainstorms, the control system is capable to maximize the reception of rainwater and to reduce the chance of overflow in Kowloon Bywash Reservoir. Upon completion of IRTS, the rainwater collected in Kowloon Bywash Reservoir will be conveyed to Lower Shingmun Reservoir when necessary. The chance of overflow from Kowloon Bywash Reservoir, as well as the flood risk in West Kowloon, will be reduced. The IRTS will also strengthen our resilience in flood mitigation for combating climate change. In addition, the storage capacity at Lower Shingmun Reservoir will be utilised for receiving the transferred surface runoff from the Kowloon Group of Reservoirs. An estimated average annual additional freshwater yield of about 3.4 million cubic metres will be generated, and the dual purposes of flood prevention and conservation of precious water resources will be achieved.